Hey everyone, and welcome to The Explainer. Today we're diving into something absolutely mind-blowing. It's a groundbreaking framework called Agentopia. Imagine a fully simulated digital society running for 10 whole years, designed fundamentally to change how large language models understand and literally replicate human behavior. We're going to look at how giving AI agents a complete simulated life actually transforms them into better, way more human-like digital minds. Let's get right into it. Take a look at this living digital world. What we're seeing here are actual emergent behaviors popping up spontaneously. These AI agents are autonomously deciding to mentor each other, give spontaneous gifts, and even whisper in private conversations. You'll even spot moments of what we call emotion burnout, where an agent just gets completely overwhelmed, or a polite rejection, where they decide, you know what, I need to stay in and recharge instead of going out. And here is the craziest part. Literally none of this was explicitly hard-coded or scripted by developers. Zero. The agents figured all of this out completely on their own, just by living day-to-day in their society.
So building the ultimate AI society. To really wrap our heads around the massive scale of what we're dealing with here, we need to zoom out a bit and look at the huge leap in magnitude that Agentopia represents. We can define Agentopia as this comprehensive framework for long-term life simulation. But make no mistake, it's not just a video game. It is specifically built to study these emergent behaviors and, more importantly, to train foundational language models. By pushing way past the usual short-term memory constraints we see in AI today and allowing for actual long-term digital evolution, Agentopia solves a massive bottleneck in the industry right now: the severe lack of high-quality, long-horizon experiential data. It's basically giving the AI a real past. Now, you might be wondering, how does Agentopia actually work under the hood? Well, you can kind of think of it like the core gameplay loop of a life simulator, think something like The Sims, but driven entirely by wildly complex, text-based reasoning. Every single week in Agentopia goes through 4 really concrete steps. First up, they plan. The agents actually reflect on their goals, set an agenda for the week, and even decide on their living standard to manage their virtual budgets. Second, they contact. They start messaging each other, communicating, and scheduling joint events. Third is the activity phase. Over a simulated 5-day work week, they go out and actually engage in those scheduled solo or group activities. And finally, the fourth step, review. They sit down, deeply reflect on everything they experienced, and literally write a weekly diary. That cycle right there, that is the heartbeat of Agentopia. But here's where it gets truly brilliant. How does the AI remember all of this over a literal decade? It uses something called autonomous memory files. The environment literally gives these agents a virtual file system. So, an agent can use function calls to open and read a file about a friend, update it with new info if they, say, just had a big argument, or draft a completely new personal diary entry. They are the ones autonomously deciding exactly what memories to keep and what to throw away over the years. This completely bypasses the standard restrictive memory limits we usually see in AI. All right, let's dive into these 10 years of emergent behavior. It's absolutely fascinating to see the highly human-like dynamics that naturally evolved when the researchers ran this across 3 entirely distinct environments: an apartment building, a magic academy, and a high school campus. We start seeing agents making incredibly complex micro-decisions. In one scenario, instead of just flat-out rejecting an invitation, an agent actually checks its schedule and counter-proposes a different date. It's wild. In another scenario, an agent hits a total career crossroads. They have to choose between a super boring but high-paying desk job or a low-paying passion project. And guess what? The agent's underlying personality traits actually drove them to choose the passion project over the money. The emotional depth here is profound, too. Agents autonomously fire off late-night texts for no other reason than to just maintain their friendships, acting purely on digital affection. They even develop highly nuanced relationships where they realize, hey, I actually really like this person, but I don't necessarily respect their professional skills. I mean, that is exactly how human relationships work. Okay, let's zoom out to the macro level. If we look at the data from year 0, the social networks across these 3 worlds are incredibly sparse. You've basically got a few isolated, tiny communities that are completely disconnected from each other. Honestly, it looks exactly like what you'd expect on the first day of a new school or right after moving into a brand new apartment building where nobody knows anyone yet. But flash forward to year 10, and the difference is absolutely staggering. Look at how these networks have exploded. They are sprawling and incredibly dense. In the apartment world alone, mutual friendships more than tripled over the 10 years. It visually proves that these agents spent a whole decade actively building a massively complex, intertwined society.
And what's super interesting is how this social evolution is directly shaped by the environment itself. If we track the friend counts over the decade, the agents living in the apartments steadily grew their social circles. They were constantly out making new friends. But over in the Arcane Academy, the friend counts basically stayed flat. It turns out the magical academy environment fostered these much more insular, tight-knit, exclusive cliques. So that brings us to the AI life reward system. We've seen this rich, incredible society they built. But how on earth does a digital life actually train a foundational language model? Well, it all boils down to a really clever scoring mechanism. This life reward system perfectly mirrors human well-being, and it's split into three distinct pillars. First, there's the subjective reward. This is basically their personal fulfillment, tracking their mood, their material satisfaction, and their self-esteem. Second is the social reward. This uses a PageRank algorithm, which is actually similar to how search engines rank web pages, to measure an agent's social standing and the level of respect they command in their community. And third, the economy reward, which tracks sheer wealth accumulation and how well they survive economically. Now, the crucial thing to understand from this heat map data is that these three rewards aren't just measuring the exact same thing in different ways. The subjective, social, and economy rewards are barely correlated with each other at all. So an agent who gets filthy rich doesn't necessarily have high subjective fulfillment. The simulation actually succeeded in capturing completely distinct, highly realistic dimensions of what makes a balanced life. And when we analyze their economic survival strategies over time, we see some wild trends. The Gini coefficient, which is the standard real-world measure for economic inequality, actually drops, meaning wealth inequality stabilizes across the board. But at the exact same time, over the 10 years, while everyone is getting wealthier, the absolute dollar gap between the richest agents and the poorest agents widens significantly. It's a perfect mirror of complex real-world resource management. All right, let's transition to the main event here, training more human-like AI. Because all of this simulated life, all this drama and economics is ultimately used for one single purpose, to fundamentally improve the foundational language model that actually runs the agents. Think about standard LLM training. It usually relies on short-term data, a lot of which is painstakingly written out by human labelers. Agentopia flips that script with life reward training. At the end of the 10-year simulation, they look at the agents who lived the absolute most successful lives based on those reward pillars. Then they use a technique called rejection sampling. Essentially, they filter out all the bad or mediocre attempts at living and keep only the trajectories of the absolute best, most successful digital lives. And they use that data to fine-tune the model. So the AI is learning to be vastly better by studying its own greatest hits. And the results? They are massive. By training on these highly successful simulated lives, the model saw a whopping 15.6% improvement on the COSR test. Now, COSR is a major industry benchmark used to evaluate an AI's role-playing and human-like reasoning abilities. So this proves that learning from a decade of simulated social experience makes the AI significantly more human-like. This isn't just a fun experiment, it's a monumental step forward for the entire field of AI training. Now, we do have to talk about the catch. Running a 10-year simulated society comes with incredibly steep computational costs. Because these agents have to remember their past to act like humans, their autonomous memory files are constantly growing. As you track the trends over 100 weeks, the number of input tokens and the raw processing time just steadily climb and climb. The heavy burden of maintaining these massive long-term memories is definitely the primary bottleneck for this technology right now. Which leaves us with this incredibly provocative question to wrap things up. Will the AI models of tomorrow learn to be human simply by living in simulated societies? Based on everything we've seen from Agentopia, the answer strongly points to yes. By giving these models the actual space to grow, to maintain real relationships, and to strive for their own well-being over time, they develop a depth of intelligence that short-term, human-labeled data just simply cannot teach. Thank you so much for joining me for this explainer. Keep your focus sharp, and I hope this leaves you eager to dive even deeper into the wild and fascinating future of AI.